So a good way to make sure that you understand what's going on in a voltaic cell is if you can draw it out. And we're always going to start with a given redox reaction, for example, this one with iron nitrate and aluminum. And if it doesn't give you the net ionic equation, go ahead and write that out so that you're canceling those spectator ions, which in this example here is the nitrate. Nitrate's all canceling out, and there's your net ionic. Now you want to divide it into two separate half reactions, which we've gone over before. So we're going to have one half reaction where aluminum is being oxidized, going from 0 to 3+, and the second half reaction where iron is being reduced from 2+ oxidation state to a neutral oxidation state. And once you've written those two half reactions and added in your electrons, you can place those on your separate electrodes in your separate containers within the voltaic cell, connect them with a wire and a salt bridge, and you have your cell drawn. So for this first example, we're going to start by sketching the cell and figuring out what the half reactions are. So like usual, we're going to start by looking at our oxidation numbers. We have silver with a +1, elemental lead with 0, and then in the product side, elemental silver and lead 2+. So we see that lead is being oxidized. Its oxidation state is increasing. So we're going to have Pb solid going to lead 2+. And then to balance charges, the +2, we also are going to have 2 electrons being produced. So lead is giving up electrons and ending up as a positively charged ion. Then for silver, the opposite is happening. We're starting with 2 silver plus ions, and on the product side, we have 2 solid silvers. So to maintain a net charge of 0 on the left-hand half, we need 2 electrons here. And we notice that that can reduce, so our final net equation for the reduction half cell will be 1 electron and 1 silver plus ion are combining to form a neutral silver atom. So those are the two half reactions, and we're going to put one in each cell. So we're going to have a solid electrode here, a solid electrode on the other side. Both of these are going to be in some sort of solution, and they're going to be connected with a wire and with a salt bridge. Now we want to label what's going on within each voltaic cell. So I'm going to choose the first half to represent my oxidation reaction here, which means that the solid electrode is going to be solid lead, and within the solution we're going to have lead 2+ ions. And then for the second half reaction, we have solid silver, so that's going to be what the electrode is made of. This will have to be some sort of silver metal. And then that's not going to be charged, but the ions that are floating around in the solution are going to have that silver with a positive charge. Now, if we were going to label the half reactions, we have a half reaction for lead, so that's going to be solid lead going to lead 2+ and 2 electrons. With a silver electrode, we have the opposite. The silver ions are going to be gaining electrons to form solid silver. So that electrode is going to be increasing in mass as the silver ions combine with electrons and plate onto the surface of the electrode. Now it wants us to label the anode and the cathode, and remember your mnemonic is AN-OX, so the oxidation reaction is going to be the anode, and that is the one with the lead. So this is the anode. And red cat reduction happens at the cathode, The reduction reaction is the gaining of electrons, which occurs over here with my silver. So this is going to be the cathode. We've already labeled which species is present in each solution. That's the lead in the left-hand beaker and the silver ions in the right-hand beaker. And lastly, we want to indicate the flow of electrons. So we see that electrons are being lost at the anode and being gained by the cathode. So that means electrons are going to be flowing through the wire in this direction. Lead is giving them up, silver is grabbing them, and there we have our half cell. And just to notice and be clear, a common misconception is that electrons flow through the salt bridge. They don't. Electrons only ever flow through the wire. But what happens through the salt bridge is that maybe we have some nitrate, whatever your spectator ion is. So let's say this is a nitrate salt bridge. So we have NO3 with a negative charge. That's going to flow the opposite direction from the electrons just to balance out the flow of charges. So negatively charged electrons are flowing from anode to cathode. Negatively charged nitrate ions are flowing through the salt bridge to balance it out.